All right, so with this then, I want to show you guys a couple of things about how you actually begin to interact with other volumes, right? Now we're getting into volumetric interpenetration, right? That's Iggy's design term. So anyway, what we have here, if you copy, you should copy another one off to the side. So the quick way is to just hit Alt and drag the gumball arrow, or you can do the copy command and move it over. What we have here is essentially an empty shell. And so what I'm going to do here is make 2 copies of this and leave one as a shell and leave the other one as a solid. Okay, so one of them will be a shell, one is a solid. So I'm going to go here, and I could just do a 4-point surface on the bottom of one of them, like this. Okay, then you select the 2 and join them. All right, so the other thing I'm going to do is intersect it with another volume. So if I just select both of these and I hold Alt and pull a copy off to the side like this, then without holding Alt, I can just kind of like shift it up in volume. In fact, I want to shift it up exactly 4 feet. And then I want to shift it forward. In this case, it's going to be -4 feet to go forward, like that. Actually, since I'm looking at that weird roof condition for me, you may not have the same. Well, actually, I think you will. But I'm going to go up another 2 feet. All right, so this is what you should have. You should have one that's solid that looks like this, and you should have another one that's not solid. So the refresher here on the Boolean functions is that if you do a Boolean difference, this is what it does, right? So it asks you to do the one to subtract from and then hit enter, and the one to subtract with and hit enter, and it actually deletes it. It also will fill in the gap, right? So remember, Boolean difference is the one that we use to punch openings, and that's why we needed the wall thickness. So the difference here is that if we also did the Boolean intersection, oh, hold on. It only gives us the intersection between the 2, right? So that's significant because when we have solids versus planes, it doesn't work that way. Because planes you have to actually just trim instead of sorry, what am I getting at? You have to trim them instead of using a function that's going to automate the result, essentially. So here, we're kind of limited in what we can trim because this model actually sticks out almost entirely below the other model, right? This model right here does not have a floor. So when I do the trim command between the 2, if I select this one as a cutting object, I can actually trim out what's inside of it. And that's all well and good. But when I try to trim out the connection between the 2, I use this, I try to trim that, I can't because it's not a complete trim. So what do you have to do in this case? Right? You would have to, actually I should just ask you guys, what do you have to do in this case?
So you want to trim that part too?
Create a line? Yeah, you could create a line. The easier way though is to create a surface, essentially. So let's see. Well, yeah. I would find it easier to do a rectangle like that, grab that curve, and just do a planar surface. So this is a temporary one. And so when I trim, I can say I want to trim, I need to go into wireframe actually, sorry. Wireframe. And I can say trim, select this and that as the cutting object, and I'm going to trim out this interior corner, right? So see how I've got that is essentially all inside the new volume. So I'm going to click that edge and it trims it out. So I'll delete that bottom, I'll delete the curve, put it back into shaded, and this is what you get. Okay, so that's semi-accurate. We would need to draw in a new slab underneath and all this stuff. But what I'm getting at here is that you need to think ahead to whether or not you want it to be a solid volume, because what you can do is Boolean union them together. And let me put this in wireframe for you real quick so you can see. Right, this looks now very similar to what this looked like a second ago. Does that seem about right? When I do a Boolean union and I select that one and this one, now they look identical. So if I go back into shaded and I take that, now they're together like this, and I explode it, and I'm just taking these off so you can see, it's exactly the same. So it's a little bit faster to do it that way and then break it down. So then now, let me go back to this. Now the great thing about that, right, so you saw that my workflow over here was to explode, build the surfaces and then extrude the bottom. Well, now I've got two planes underneath my model that I can just very quickly switch over to slab, extrude surface, -1 foot, solid equals yes. And there they are. I happen to put it on the wrong layer, but there they are, right there, for both of them. And what's more important, this one is accurate. So I'll pull this back, and let me turn this on so that you can see it in perspective. There we go. Now you have the step in your space that you're looking for. So, what questions do you have? Yes?
Mine is not letting me do the Boolean union.
Okay, I'll come take a look.
So which Boolean is kind of difference?
Yeah, it's an order of operations thing, right? So if you want to use, if you know your colliding volumes, Boolean union them first because it eliminates those interior connections without you having to do too much work. Okay, so I'm going to come around and make sure that you guys can get to this point with this model before we move on.
So we're going to make this Boolean both together, Boolean onion, and after that it's going to be inside, it's going to be apple.